So hold your hand up right in front of your face for a second.
Okay, doing it.
Yeah. Now, take a look at it, and then look at the space between your hand and your eyes.
Right.
Because standard physics, the kind most of us learned in high school and college, it tells you that the space you're looking at is essentially empty.
A total void.
Exactly, a void. I mean, sure, there are some oxygen and nitrogen molecules floating around in there, but fundamentally, the backdrop of reality is taught as this giant cosmic billiard table.
Right, with hard, discrete little balls.
Yeah, your protons, your electrons, your photons, and they just bounce around, completely isolated from one another in this massive, featureless vacuum.
It's a very clean, atomized view of reality.
It really is. It's like there is stuff, and then there is, well, not stuff.
And honestly, it is an incredibly comforting model, which is probably why humanity has clung to it for so long.
Yeah, we like our neat little boxes.
We do. We like things to be categorized. We want to point at a physical particle and say, with absolute certainty, there is an object, and then point at the vacuum next to it and say, there is nothing there. It just aligns perfectly with our macro-level primate brains, honestly.
We pick up a rock, we throw a rock.
Exactly. The rock is separate from the air it flies through.
But, and this is where today gets wild, you step into the world of trans-dimensional unified field theory, and suddenly that billiard table just vanishes from underneath you.
It completely disappears.
If the material we are diving into today is correct, we are looking at a cosmological landscape that is entirely continuous.
No empty space at all.
Right, that empty air between your face and your hand isn't empty at all. It is a highly dense, continuously moving crystalline grid.
We are talking about a total paradigm shift here, moving from the isolated particle model to a single, infinite, self-similar, recursive fractal field.
Which is quite the mouthful.
It is, yeah. But to use a macro analogy, the universe is not a pool table, it's an ocean.
And that ocean is exactly what we are swimming in for this deep dive.
Grab your scuba gear.
Seriously, because the mission for our session today is ambitious, to put it mildly. We're going to entirely deconstruct our fundamental understanding of the universe.
No small task.
No small task at all.
Right.
But I know you're tuning in because you love those moments of sudden clarity.
That feeling of suddenly seeing the matrix behind the curtain.
Exactly. And doing it without having to spend 10 years getting a PhD in advanced mathematics.
Which is always a plus.
Right. So we are looking at an incredibly dense theoretical physics framework known as Transdimensional Unified Field Theory, or TDUFT.
Authored by George James Dukas.
Yep, published in 2026. Our primary source material is a highly technical, comprehensive treatise, literally titled fractaluniverse.pds.
The title says it all, really.
It does. And the core thesis. The standard model of particle physics, the one the global scientific community has relied on for decades, is fundamentally flawed.
Flawed because, as Dukas argues, it's looking at the universe entirely backward.
Okay, let's unpack this. The author presents this profound critique of modern physics, right?
Yeah, he argues that we've spent the last century mistaking the ripples for the water.
That's such a great way to put it.
I mean, think about it. We build these massive machines to study the ripples, we name the ripples, we categorize them based on how they splash.
And we completely ignore the fluid medium that is actually doing the waving.
Exactly. We ignore the water itself.
So let's unpack this from the ground up, starting with what the document calls the master layer.
This is the foundation of it all.
Right. And, the math in this treatise is incredibly dense, but the underlying geometry, the physical picture it paints, is surprisingly intuitive once you get the hang of it.
It really is.
So, if the universe isn't a vacuum filled with isolated particles, what actually is it?
Well, TDUFT states the universe is a single colattice field.
And the Q stands for quantum, right?
It does, but not in the sense of isolated quantum particles. Imagine an infinite, multidimensional crystalline grid.
Okay.
But this isn't a static crystal. It's not like a diamond sitting in a museum case. It is alive, it is moving, and crucially, it is recursive.
Meaning it repeats itself.
Yes, it repeats its structural patterns at different scales, which is the foundational definition of a fractal.
Hence the title of the paper.
Exactly. Dukas introduces a master fractal field equation for this lattice. And without getting bogged down in the calculus right out of the gate, this master equation basically describes the continuous evolution of this field across all possible dimensional tiers simultaneously.
I want to pause on that because the implications there are just massive.
They really are.
I mean, standard physics has a whole library of different equations for different phenomena.
Oh, yeah. A completely fragmented approach.
Right. We have electromagnetism to explain light and magnets. We have the
Yeah.
Higgs mechanism to explain how particles get mass.
We have the strong nuclear force to explain how atomic nuclei don't fly apart.
Exactly. And they are treated as separate, independent laws of nature that we've had to sort of clumsily stitch together.
And that clumsy stitching is exactly what we call the standard model today. But what's fascinating here is that in TDUFT, those forces are not separate. Every single one of those phenomena, electromagnetism, mass generation, strong interactions, they emerge merely as discrete projections.
Like special cases of this single fractal equation.
Exactly that.
So wait, if I'm tracking this, let me try a real-world visualization here.
Go for it.
Let's say I'm holding a ceramic coffee cup.
Okay, standard morning routine.
Right. So standard physics says that cup is made of trillions of tiny, discrete atoms. There are electromagnetic forces holding the electron clouds to the nuclei. There's a strong force holding the protons together inside the nuclei. And there's gravity pulling the whole thing down toward the Earth.
All different forces, all different particles.
Right. So are you saying this theory views the cup, the hot coffee inside it, the steam rising from the surface, and the literal empty space between my hand and the cup, all of that is just different ripple patterns in the exact same infinite sheet?
That is exactly what I'm saying. The cup is a highly dense, folded, geometric knot in the field.
Huh.
Yes, the empty space is the same field, just smoothed out, resting at a lower dimensional frequency.
So there are literally no particles.
There are no particles in the traditional atomized sense. A particle is just a localized resonance, a specific stable vibration on this infinite dimensional lattice.
It kind of reminds me of watching a turbulent river.
How so?
Well, you look at the water flowing over some rocks,
Yeah.
and you see a whirlpool form.
Right, yeah.
You could point at that whirlpool and say, oh, there is a discrete object. I'm going to name it a whirl particle.
I love that. A whirl particle.
Right. You could measure its diameter. You could measure its spin velocity.
Yeah.
But it isn't a separate object. It's just the river folding in on itself in a highly specific, localized way.
And if you take the river away, the whirlpool doesn't exist.
Exactly.
That analogy holds up beautifully when applied to the Cladis.
Oh, good.
If we connect this to the bigger picture of cosmology, the idea that empty space is simply the flat, unknotted state of the field means that distance and separation are, well, they're sort of illusions.
Wow.
Yeah, everything is deeply physically connected through a stable, recursively structured medium. When you wave your hand through the air, you aren't moving through nothingness.
What am I doing then?
You are dragging a complex, highly folded geometric disturbance through an infinitely dense structured medium. You're actually rearranging the lattice as you move.
Which means the universe isn't just random noise.
No, not at all.
Because if everything is just a ripple or a whirlpool on a single field, there have to be rules governing how those ripples expand, how they contract, and how they form stable structures like my coffee cup, rather than just immediately dissipating into chaotic static.
You hit the nail on the head. The rules governing that construction are entirely geometric, and they operate on a fundamental mathematical baseline.
Okay, and this brings us to the operational heart of TDUFT.
Yes, the two primary operators.
Right, they're two numbers, essentially, that run the entire universe. The document refers to them as the golden pair.
We're talking about phi and psi.
Okay, phi. I think a lot of people have heard of phi, the golden ratio. It's roughly 1.618.
Very famous number.
Yeah, we see it in art, in architecture, and obviously in nature. The spiral of a nautilus shell, the arrangement of seeds in a sunflower.
The arms of a spiral galaxy.
Exactly. It's aesthetically pleasing, and mathematicians have loved it for centuries.
But Dukas takes it far beyond biological aesthetics. He elevates phi to the foundational building block of physical space.
And he pairs it with his inverse counterpart, right, psi.
Psi, which is approximately negative 0.618. Both of these numbers emerge from one incredibly simple quadratic equation. X squared minus x minus 1 equals 0.
Just from that one equation.
Yep. If you solve for x there, you get exactly two answers, and those answers are phi and psi.
I mean, I understand the math, but how do these two numbers function in the context of the universe being an ocean? Like, what do they actually do?
Think of them as the fundamental opposing actions of the universe. There is a strict division of labor here.
Okay.
Phi is the expansive operator. It governs outward radial scaling. It literally builds space.
It pushes out.
Yes, it pushes the lattice outward, creating the expansive arena of the universe.
So it's like phi is the accelerator. It's pushing reality to grow,
Yes, and psi is the contractive operator.
and its value is negative.
Exactly. Notice it's negative. It governs inward dimensional descent, torsion, and crucially, it governs time.
Wait, time. So phi governs the expansion of space, and psi governs the contraction of time.
In a geometric sense, yes. The inward twisting, the torsion of the field is what gives us the progression of time and the localized density of mass.
That is wild.
And the truly elegant part of this mathematical pairing is what happens when you multiply them together.
Oh, heck.
If you multiply phi by psi, so 1.618 times negative 0.618, the product is exactly -1.
Not roughly -1, but
Exactly -1. It encodes a perfect inherent space-time duality.
Why?
Expansion multiplied by contraction equals a perfect, balanced mathematical inversion. It shows that the universe is a closed, perfectly balanced system.
I'm picturing, phi is the accelerator, pushing the universe to grow outward into space, and psi is the steering wheel and the brakes, twisting it inward into time and mass.
That's a perfect way to visualize it.
They're just perfectly balanced.
They are, and they come together in a specific mathematical identity that Dukas calls the eternum nexus.
The eternum nexus. Sounds like a sci-fi movie.
It does, but as a physicist, looking at this specific equation is arguably the most breathtaking moment in the entire treatise.
Really?
Oh, yeah. It synthesizes geometry and motion into a single statement.
Walk us through it then. How does the eternum nexus visualize this balance?
So the equation is written as L squared equals pi squared times e to the power of I times phi squared times theta.
Okay, let's break that down because e to the power of I times phi squared theta sounds like alphabet soup to anyone who hasn't taken advanced calculus recently.
Fair enough. Let's look at the two sides of the equation. On one side, you have pi squared.
Okay, pi.
Pi, as we know, governs the geometry of circles and spheres, so pi squared represents structural spherical closure.
The static shape.
Right. It is the static physical shape of the field.
Hmm.
The lattice inherently wants to enclose itself into a stable spherical shape.
He wants to form a bubble.
Exactly, a bubble. But on the other side of the equation, you have that e term. In mathematics, whenever you see e raised to an imaginary number, I multiply by an angle, which is theta. Here you are looking at an oscillatory wave function.
Okay, so a wave.
It describes something rotating or waving. In this case, it is a torsion wave driven by the golden ratio, phi squared.
Torsion meaning a twisting motion.
Exactly that. So when you put these two halves together in the eternum nexus, the equation is literally telling you that the universe isn't just a static crystal grid.
It's not frozen.
No, it's not a frozen block of geometry. Because of that wave term, the universe is a breathing, twisting, torsion wave machine.
A breathing wave machine.
Yes. It is constantly expanding outwardly driven by phi, attempting to close into perfect spheres governed by pi, and twisting back inwardly governed by psi.
Wow.
It is violently, dynamically alive at the microscopic level.
Okay, but how does a breathing, twisting wave machine actually build hard physical reality?
That's the million-dollar question.
Right, because we have this infinite ocean of energy expanding and contracting, making spherical ripples. But how do we get from abstract golden ratio math to a planet, or a table, or an electron? How does geometry crystallize into mass?
This is where TDUFT introduces the D ladder, or the dimensional ladder.
The D ladder.
Yeah. The universe doesn't just smoothly slide from one state of complexity to another. It builds itself in discrete geometric steps.
That's okay.
It clicks into place like architectural scaffolding, moving from the simplest possible geometry up to incredibly complex structures.
Okay, let's walk up this ladder then.
Sure.
The document says it starts at the absolute minimum requirement for geometry, which is D1.
Dimensional tier 1.
Right, what is D1?
D1 is simply a one-dimensional segment, a line. Two nodes connected by a single edge.
But a line isn't stable. It's open. It doesn't have an inside or an outside.
Exactly. It doesn't enclose anything, so it can't trap the energy of the field.
Because it's open.
Right. Because it's open, the expansive operator, Gale phi, pushes the lattice outward to find the next stable geometric state. This takes us up the ladder to D2.
Which would be a two-dimensional triangle. 3 points, 3 edges, and 1 flat face.
Yes. And according to TDUFT, this D2 tier is the domain of the photon wavefront, light.
Wait, light is a triangle.
Light lives on this flat 2D geometric plane. It propagates across the universe as a flat geometric wave.
Okay, but a triangle still doesn't enclose a volume. It's flat.
Right.
Hey, if you lay a triangle flat on a table, it doesn't hold any water. To get true physical substance, to get what we call matter, you need volume. You need an inside and an outside.
Exactly. So the lattice has to step up the D ladder one more time.
Taking us to D3.
Yes, a three-dimensional tetrahedron, a pyramid with a triangular base.
4 points, 6 edges, and 4 faces.
And this is where we encounter the concept of Euler ceiling, which is arguably the most critical structural concept in the entire theory.
Named after Leonhard Euler, right? The 18th century mathematician.
The very same. He essentially invented graph theory and topology. He discovered a topological invariant, a hard mathematical rule that applies to 3D shapes.
The rule is V minus E plus F equals 2. Vertices minus edges plus faces must equal exactly 2 for a geometric shape to be a closed, stable, three-dimensional object.
Yes. And the brilliance of Ducas's work is applying Euler's topological rule to the literal fabric of the universe.
Oh, wow.
A dimensional tier is only stable when it fulfills this topological law. So let's test our D ladder against Euler's invariant.
Okay, let's do the math. D1, the line segment, it has 2 vertices minus 1 edge plus 0 faces. 2 minus 1 plus 0 equals 1.
And it doesn't equal 2.
So D1 is unsealed. It leaks energy.
Now D2, the triangle. 3 vertices minus 3 edges plus 1 face. 3 minus 3 plus 1 equals 1.
Still not 2.
D2 is also unsealed.
Which means light, living on the D2 plane, is essentially an unsealed geometry. It can't hold still. It has to keep moving because it hasn't achieved structural closure.
Exactly. But now look at the D3 tetrahedron. 4 vertices minus 6 edges plus 4 faces. 4 minus 6 is negative 2. Plus 4 is exactly 2. The tetrahedron satisfies the Euler topological invariant perfectly.
Wow.
D3 is the first true volumetric closure in the universe. It creates an inside and an outside. It traps the energy of the field.
And in TDUFT, this geometric closure is the literal definition of mass.
Yes. Mass isn't a magical substance that you drop into an empty universe. Mass is the geometric event of a 2D plane folding into a sealed 3D volume.
Let's just dwell on this for a second because the implications for modern physics are staggering. This completely redefines what matter actually is.
It really does.
We have to talk about the Higgs boson in this context because the Higgs discovery in 2012 was heralded as the ultimate triumph of the Standard Model.
Oh, absolutely. I mean, the media loved calling it the God particle.
Standard physics views the Higgs field as a sort of invisible molasses that permeates the universe.
Right. They believe that fundamental particles, which supposedly have no inherent mass, gain their mass by dragging through this molasses.
Some particles interact with it more strongly, so they are heavier.
Exactly. And to prove this, they built the Large Hadron Collider at CERN.
Smash protons together at unimaginable speeds.
And look through the chaotic debris for a specific signature.
And they found it. A resonance peak at 125 GeV, which is roughly 133 times the mass of a proton. And they declared they had found the discrete particle responsible for giving everything in the universe mass.
But TDUFT looks at that exact same data from CERN and completely flips the interpretation.
It fundamentally reframes the discovery. In TDUFT, that 125 GeV resonance isn't a discrete particle at all, is it?
No, it is literally just a dimensional closure event at the gate between the flat D2 plane and the enclosed D3 volume.
So mass isn't something a particle possesses.
Mass is what happens when a flat light wave folds into a sealed Euler tetrahedron. The mass is the geometry.
Notice how beautifully this simplifies the mechanics of the universe.
It does away with so much clutter.
You don't need to invent a magical, invisible molasses field. And you don't need to invent a unique particle to act as the ambassador of that field.
Mass is simply the inevitable consequence of the lattice following Euler's topological rule to achieve structural stability.
The lattice clicks from a flat triangle into a sealed pyramid, and boom, you have mass. It's structural tension resolving itself.
Beautifully said.
But I have to play devil's advocate here for a minute.
Please do.
I can just hear experimental physicists shouting at their speakers right now. If mass is just a geometric folding event, shape changing into another shape, why do the detectors at CERN actually record something that looks and acts like a particle?
It's a vital question.
They see an entity with a specific mass of 125 GeV, and then it decays almost instantly into other particles. It behaves exactly like a discrete object.
And Ducas addresses this disconnect explicitly. What the detectors at CERN are recording is real data. The machine isn't lying. But the physicists' interpretation of that data is backward because they are viewing it through the lens of atomized billiard balls.
They're looking for a ball.
Right. They assume that a spike in energy must equal a discrete spherical object popping into existence. But what they're actually seeing is a resonance peak of the lattice itself.
Let's try to visualize that resonance peak without the math, just for a second.
Sure. Think of a large, flat sheet of flexible metal. If you push on the center of it hard enough, the metal will suddenly snap from being flat into a bowed-out 3D dome shape.
Okay, I can picture that.
When it pops into that new geometry, what happens?
Well, it makes a loud noise. Like a metallic thwack, it reverberates.
Exactly, it rings. That 125 GeV measurement at CERN is the cosmic equivalent of that metallic thwack.
Wow.
It is a geometric tension, the sheer energy required for that flat D2 plane to snap into a sealed D3 volume. It is the acoustic signature of the universe closing a shape.
And what about the decay time? The standard model says the Higgs particle only lives for a tiny fraction of a octosecond before decaying.
That incredibly short lifetime isn't a particle dying.
And what is it?
It is merely the time scale of that geometric structure forming, resonating, and dissipating its tension into the surrounding detector field. Mass isn't a lifespan, it's the peak structure showing up in the collision data.
So, we've been trying to study the acoustic properties of a ringing bell by assuming the sound itself is a tiny, invisible baseball flying through the air.
That's exactly what we've been doing. It's a complete miscategorization of the phenomena.
We have been misinterpreting the structural resonances of the fluid medium as isolated, solid objects.
Precisely.
Okay, so if we accept this premise that light lives on the unsealed, flat D2 plane and matter lives on the sealed D3 plane, that brings up an incredibly interesting question about light itself.
Yes, it does.
We all know light travels at the speed of light, almost exactly 300 million meters per second. But why does it travel at that specific speed?
In the standard model, the speed of light, c, is simply an empirical measurement.
They just measure it and that's it.
Yeah, they measure it, they plug it into their equations, and they accept it as a fundamental constant of nature. They have no underlying mechanism to explain why it is that specific number.
It's treated as an arbitrary speed limit enforced by the universe.
But TDUFT, however, derives the exact speed of light purely from the geometry of the D ladder.
And this is detailed in the text as the speed of light clause or the N-Tor velocity structure.
Right.
The treatise provides an equation that calculates c without ever having to measure a physical photon. It states that c equals 2 plus phi to the negative 1 plus phi to the negative 2 minus epsilon, all times 10 to the 8th.
Let's translate that equation into the geometric physical reality we've been discussing.
Yes, please.
The 2 at the very beginning of the parenthesis represents the baseline D2 photon plane, the unsealed flat geometry where light propagates.
The two-dimensional triangle.
Yes. Then you add the golden ratio components,
Right.
phi to the negative 1 plus phi to the negative 2. Now, due to the unique inherent properties of the golden ratio, those two terms added together equal exactly 1.
The text refers to this mathematical addition of 1 as the harmonic increment lifting toward D3.
Yes.
So the equation is literally showing the D2 plane attempting to step up the D ladder toward the sealed volume of D3.
Exactly, yeah. It is the mathematical pressure of the expansive phi operator.
Yeah.
So you take the baseline 2, you add the harmonic increment of 1, and you get exactly 3.
Right.
You multiply that by 10 to the 8th, which represents the dimensional recursion depth of the lattice, and you get exactly 3 times 10 to the 8th meters per second.
Just 300 million.
It is a perfect, clean, theoretical number derived entirely from the golden ratio and the geometry of a triangle attempting to become a pyramid.
But, and here's where it gets really interesting, the actual measured speed of light in a vacuum isn't exactly 3 times 10 to the 8th meters per second.
No, it's not.
We know it's slightly less.
Yeah.
It is 299,792,458 meters per second. Why isn't it the perfect mathematical ideal?
Because the universe isn't a perfect frictionless math equation, which brings us to the final term in the N-Tor structure, minus epsilon.
Epsilon.
Epsilon is the attenuation term. Dukas utilizes a Ramanujan-Rogers continued fraction to calculate this specific drag on the light wave.
Okay, a continued fraction, for anyone who hasn't stared at infinite math lately, is a fraction where the denominator keeps going indefinitely.
Right. A number over a number plus a number over a number.
Stretching down into infinity. It visually looks like a fractal descending into a bottomless pit. But what does that math actually mean in physical terms? How does an infinite mathematical series relate to light slowing down?
Well, we established that the D ladder moves from D2 to D3 to create mass. But the ladder doesn't stop at D3.
It keeps going.
It continues into infinite higher dimensional recursion, D4, D5, D6, all the way up to incredibly complex macro structures.
Okay.
Because the universe is a single interconnected fractal field, all of those higher, incredibly dense structural tiers are physically stacked on top of the fundamental D2 plane.
Like layers of deep water pressing down on the currents below them.
A great way to visualize it. As the flat D2 photon wave tries to propagate across the universe, it has to drag the weight of these infinite, microscopic, recursive structures along with it.
Oh, wow.
It experiences a tiny, tiny amount of structural resistance. That Ramanujan-Rogers continued fraction mathematically models the infinite descent of those higher dimensions pulling back on the light.
So it's drag.
Yes. The epsilon term represents harmonic leakage. It is literal dimensional friction.
Like the universe charges a tiny dimensional friction tax for moving through its infinite structure.
Exactly, a dimensional friction tax.
Without that epsilon term, without that drag from the higher dimensions, the universe would be a perfect static math equation, and light would travel exactly 3 times 10 to the 8th.
Right.
But because there is this infinite depth of higher geometry leaking down, it slows the light down just a fraction of a percent. And that tiny bit of friction gives us a finite, measurable, physical reality instead of infinite, blinding perfection.
The profound takeaway here is what the existence of dimensional friction implies about the universe. If we connect this to the bigger picture, if there is friction, there is texture.
Texture.
It means the vacuum of space isn't perfectly smooth.
Well, friction requires resistance, and resistance requires a physical structure to push against. If the vacuum was truly empty, light wouldn't experience drag.
Precisely. And this specific realization that empty space has a physical texture, a grain to it, brings us to the absolute biggest conflict between TDU-FT and mainstream physics.
The overturn of quantum chromodynamics, or QCD.
Yes, we have to discuss QCD.
QCD is the math that governs the strong nuclear force. It explains how quarks are held together inside protons and neutrons. And the entire foundation of QCD, and by extension the Standard Model, absolutely relies on the strict assumption that the vacuum of space is perfectly smooth.
Perfectly smooth.
It must be isotropic, meaning it is exactly the same in all directions. It must be a Lorentz invariant.
Yep.
Look up, down, left, or right. The vacuum must offer zero resistance and have zero structural variation.
It is the bedrock of their calculations. If the vacuum has a texture, if it resists movement differently depending on which direction you're facing, the incredibly delicate math of QCD completely shatters.
Shards everywhere.
Yeah.
But Dukas is arguing that the vacuum is a crystalline lattice. It has a structure governed by the eternum nexus. It has psi-psi torsion.
Yes.
So we have a massive theoretical collision here. Does empty space has a texture, or is it a perfectly smooth void?
To settle this, TDU-FT doesn't just rely on theory, it points to historical, empirical data.
The Brillat-Hall experiment.
Specifically, yes. The Brillat-Hall experiment conducted in 1979 in Colorado. Elaine Brillat and John L. Hall set up a highly sensitive laser interferometer on a massive, stabilized rotating table.
Okay.
Their goal was to measure if the speed of light varied even slightly depending on which direction the laser was pointing as the table rotated.
They were looking for the ether wind. If space has a texture, rotating the laser through that texture should cause measurable drag.
According to the Lorentz invariant assumption of standard physics, they should have found exactly zero variation, a perfect flat line zero, no matter which way the laser pointed.
Well, they didn't find zero.
No, they didn't. They detected a tiny, persistent anisotropy, a direction dependence in the speed of light. It was an incredibly small variation, roughly 2 × 10⁻15.
2 parts in a quadrillion. I mean, it is a microscopic variation.
It is microscopic, but in physics, microscopic is not zero. Standard physics, however, largely waved this result away.
Because it broke their math.
Exactly. Because a variation of 2 × 10⁻15 breaks the math of QCD, the mainstream community assumed it had to be a systematic error.
They blamed the equipment.
Or thermal noise, or mechanical vibration in the rotating table. They needed the vacuum to be smooth, so they treated the data as an anomaly.
But TDU-FT looks at that exact same data from 1979 and says, no, your equipment was fine. You actually measured the grain of the universe. How does TDU-FT explain the mechanics of why the laser experienced that specific drag? Why does the speed of light change depending on the direction?
We have to remember that the Earth is not just a dead rock floating in an empty void. In the TDU-FT framework, the mass of the Earth represents a highly dense, rotating psi to the 4th contraction node.
Okay, so it's a massive, complex knot of twisted, folded psi geometry.
Yes. As this massive geometric knot spins on its axis and orbits the sun, it is physically moving through the wider philatus of the solar system.
It's like a massive spinning bowling ball being dragged through a dense foam.
That is an excellent visualization. As the Earth spins, it physically drags on the lattice, it twists the local fabric, it breaks the local isotropy.
It distorts the field.
The math in the treatise refers to this as creating a quadrupolar perturbation in the dimensional friction.
Let's translate quadrupolar perturbation for the listener.
Think of the Earth compressing the lattice in front of its rotational path and stretching the lattice behind it. It creates a physical distortion field. Remember the epsilon drag term we discussed earlier?
The dimensional friction tax.
Right. The Earth's physical rotation through the lattice actually modulates that epsilon drag. It creates a slight rhythmic harmonic ripple in the resistance of the vacuum.
Wait, so because the Earth is a giant spinning knot of folded geometry, it actually distorts the empty space around it just enough to change the speed of light depending on whether you are measuring with the grain of the lattice or against it.
Yes. The Brillat-Hall experiment didn't measure equipment noise. It measured the literal topological wake of the Earth twisting the lattice.
That is incredible.
And because this structural wake exists, the assumption of a smooth isotropic vacuum is dead. You can no longer use the continuous, untextured math of quantum chromodynamics.
If QCD is dead, how do quarks hold together then?
TDUFT replaces QCD's concept of asymptotic freedom, this idea of smooth, continuous running of forces with discrete geometric resonances. You don't need a perfectly smooth vacuum to hold atomic structures together. The inherent topological torsion of the higher dimensional layers, specifically the D6 layer, provides the binding force geometrically.
So up until this point, our deep dive has been heavily theoretical. We've talked about the shape of the universe, golden ratios, dimensional ladders, and tiny fractional changes in the speed of light.
Very abstract concepts.
It's fascinating, but it can feel abstract. However, if this math is real, if the universe actually is a manipulatable geometric lock rather than a chaotic soup of billiard balls, it implies we should be able to engineer reality in ways that currently sound like pure science fiction.
That is the ultimate test of any physics theory. If you truly understand the underlying code of reality, you can write new software. You can manipulate the field.
Which brings us to the applied technology section of the document, specifically the parameters for what Dukas calls antimatter V2.
Antimatter V2.
Let's look at how we currently manufacture antimatter. Right now, humanity relies on brute force. We build massive, multi-billion-dollar subterranean particle accelerators like CERN.
Right.
We take protons, speed them up to 99.9% the speed of light, and smash them into each other with incredible violence, hoping that in the resulting chaotic explosion, we might catch a few fleeting atoms of antihydrogen.
It is the equivalent of trying to figure out how a Swiss watch works by hitting it with a sledgehammer and looking at the gears that fly out.
Exactly.
But because TDUFT views the universe as a fluid fractal field governed by precise geometric rules, you don't need to smash things to change them.
You don't need a sledgehammer.
No, you simply need to trigger a geometric inversion. You just need to untwist the knot.
The document makes a stunning, highly specific claim here. It states you can create antimatter on a standard laboratory tabletop.
On a tabletop.
You don't need a city-sized collider. You need a low-power, 200-milliwatt, 808-nanometer circularly polarized laser fired into a chamber of neon gas.
To put that hardware into perspective, a 200-milliwatt laser is only slightly more powerful than a high-end presentation laser pointer. It uses negligible electricity.
How does a laser pointer create antimatter? The text says that if you hit the precise D6 magnetic torsion layer of the neon atom with light that is mathematically resonant with phi squared, you cause a torsion chirality flip.
A torsion chirality flip.
Explain the mechanics of that flip. How does a light wave turn normal matter into antimatter?
Think of an atomic, the structure of a normal neon atom, not as a physical whole, but as a whirlpool in our lattice ocean.
Okay, the whirl particle again.
Let's say normal matter is a whirlpool spinning clockwise. It has a specific chirality, a specific handedness. CERN tries to destroy the whirlpool by dropping a bomb into it.
Right.
TDUFT says, don't use a bomb. Just send a perfectly tuned wave, the circularly polarized laser that matches the golden ratio frequency, phi squared, of the whirlpool's outer edge.
Okay.
Because the laser is circularly polarized, it introduces a highly specific counterspin to the geometry of the well.
So it catches the edge of the whirlpool and forces it to spin the other way.
Yes. It geometrically unwinds the atomic well and immediately rewinds it in the opposite direction, counterclockwise.
Wow.
You haven't violently destroyed the atom. You have simply inverted its geometry. You flip its charge.
Turning normal matter into positrons.
At a claimed rate of 1,000,000 per second per cubic centimeter using the power equivalent of a light bulb.
The ability to manufacture a steady stream of antimatter positrons on the fly with no massive infrastructure.
Mhm.
I mean, that fundamentally alters the trajectory of human technology.
It changes everything.
The text outlines 3 immediate applications for this torsion chirality flip, and they are straight out of a space opera. Number 1, zero-point propulsion, starships.
Currently, human space travel is violently constrained by the tyranny of the rocket equation.
The heavier you are, the more fuel you need.
Right. To move mass through space, you have to burn heavy chemical fuel to create thrust. But carrying that fuel makes the ship heavier, which means you need to carry even more fuel to push the fuel you are carrying. It is wildly inefficient.
It really is.
TDUFT proposes abandoning chemical thrust entirely. It proposes a thrust vector driven by an antimatter-catalyzed positive ion plasma sheath.
Walk us through how that works. Instead of a rocket nozzle blowing fire out the back, what is the ship doing?
By manufacturing antimatter directly on the hull of the ship using these tabletop lasers triggering local geometric inversions, the ship can create a highly charged plasma sheath.
Okay.
This sheath interacts directly with the D4 force extraction layer of the lattice.
So it's engaging with the lattice itself.
Yes. The ship doesn't push against its own fuel. It geometrically induces a directional thrust directly against the fabric of space itself.
It's pulling itself along the lattice instead of pushing itself through a vacuum.
Exactly.
The text claims this method would drop onboard power requirements by 8 orders of magnitude. It's essentially anti-gravity.
It is geometric displacement. And as revolutionary as that is, the second application pushes the boundaries even further.
Stargates. Spatial transit without moving through the intervening space.
Now we are truly entering the realm of science fiction. The problem with teleportation in standard quantum physics is the Heisenberg uncertainty principle.
You can never know the exact position and momentum of a particle simultaneously.
Right. So if you try to disassemble a physical object, beam it across empty space, and reassemble it, that inherent quantum fuzziness means you have a massive probabilistic arrival uncertainty.
You might try to teleport into a room and end up materializing halfway inside a solid wall because the coordinates drifted.
Which is obviously a problem. It makes teleportation practically impossible in a vacuum model.
Right.
But remember, TDUFT says space isn't an empty vacuum. It is a highly ordered, mathematically precise Q-lattice. The Stargate concept described in this document involves tying the spatial transit coordinates directly to the discrete geometric atomic shells of a target element.
They specifically mention using neon, locked into the n equals 10 to 20 harmonic ranges.
Yes. You aren't aiming your teleportation beam at a set of invisible GPS coordinates floating in an empty void. You are phase-locking the transit gate to the literal physical structural nodes of the neon atoms at the destination.
It's like threading a needle. If the universe is a continuous crystalline fabric, you don't throw the object through the air, you pull it along a specific thread woven into the fabric.
Perfectly said.
The transit frame is physically pinned to the atomic nodes of the lattice, which completely removes the probabilistic drift. You arrive exactly where the geometric lock dictates you arrive.
You are treating the atomic structure of reality like a cosmic combination lock. You aren't trying to blow the safe door off its hinges with a particle accelerator. You are gently picking the lock with a 200 milliwatt laser tuned to the golden ratio.
Which perfectly sets up the third and perhaps most globally disruptive application, zero-point energy extraction.
Drawing limitless power directly from the vacuum.
This is the holy grail of physics. Even standard physics acknowledges that the vacuum contains immense amounts of zero-point energy.
But they view it as chaotic, random quantum fluctuations that we cannot extract useful work from.
Right.
TDUFT, however, proves the vacuum is structured. If you use the antimatter torsion flip we discussed, you can purposefully create a pressure differential in the lattice, pumping energy directly out of the D10 zero-point domain into our D3 reality.
And the most compelling part of this section is that Dukas claims this isn't just theoretical math. He provides the exact methodology for empirical verification.
He does.
He states that if you run this chirality flip and hook the output up to a multi-channel analyzer, histogram screen, you won't see random quantum static.
If the vacuum were random, you would see a smooth Gaussian bell curve of noise. But Dukas claims you will see razor-sharp, discrete delta peaks spaced exactly according to the golden ratio.
He provides the exact nanosecond timing intervals, too. 142, 120, 95, 72, and 52 nanoseconds.
It's a cosmic barcode.
A barcode. If you run the experiment and see those exact delta peaks with that exact mathematical spacing, it is unfakeable, definitive proof that the device is successfully drawing structured power from the underlying torsion fields of the lattice.
It would prove the geometric ether is real.
The ability to verify the theory with tabletop electronics rather than billion-dollar colliders is what makes this treatise so incredibly dangerous to the established physics paradigm.
It democratizes the validation of reality.
Yeah, exactly. Now, as we wrap our heads around all of this, I want to take a step back and clarify a visual point. We've used the word fractal repeatedly to describe the universe today.
We have.
When most people hear the phrase fractal universe, their minds immediately conjure up a very specific, famous image. The Mandelbrot set.
Oh, yeah. The infinitely repeating, highly psychedelic, sort of bug-shaped geometry that was on half the dorm room posters in the 1990s.
Exactly that one. It's beautiful and it zooms in infinitely. But Dukas explicitly includes an entire appendix, Appendix B, dedicated solely to warning the reader against making this exact comparison.
He titled it, "Why the Mandelbrot Set Does Not Describe the Universe."
Why is he so adamant about separating TDUFT from the most famous fractal in mathematics?
Because relying on the Mandelbrot set represents a fundamental misunderstanding of what a physical universe actually requires to exist.
Okay, break that down for us.
The Mandelbrot set is generated by the equation z sub n plus 1 equals z sub n squared plus c. It is a two-dimensional, complex, plane mathematical object. Crucially, it functions as a binary classifier.
Meaning it essentially just asks a yes or no question about a coordinate.
Yes. It tests whether a point's orbit escapes to infinity or whether it remains bound near the origin. The famous, beautiful image we look at isn't a solid object. It is merely the boundary line between stability and divergence.
A boundary.
It is what mathematicians call a boundary fractal. It is almost entirely edge. It has no interior volume, no radial scaling, and no complex internal physics.
Let me try to put that into a fractal analogy just to make sure I'm getting this.
Saying the universe is a Mandelbrot fractal is like looking at a satellite photograph of the California coastline and claiming that the 2D line, where the sand meets the water, is the exact same thing as the entire Pacific Ocean.
That's a great analogy.
The Mandelbrot set is just the coastline. It's a pretty edge. But TDUFT is the ocean itself. The deep underwater currents, the crushing thermal pressure, the volume, the internal life.
That is an exceptional way to phrase it. A physical universe capable of supporting matter and energy requires a continuous, dense interior field.
Right.
It requires the D ladder to step up through dimensions. It requires Euler-sealed surfaces to create mass. It requires the deep torsion layers to extract zero-point energy.
And the Mandelbrot set possesses none of those mechanics.
None of them. It is mathematically gorgeous, but physically sterile. The TDUFT universe is a field fractal defined by infinite depth and volume, not a flat boundary fractal defined by an edge.
Well, we have covered an immense, almost overwhelming amount of ground today.
We really have. We started by taking the comforting pool table of the 20th century universe, with its isolated atomized billiard ball particles, and we replaced it with an infinite, self-similar, vibrating lattice ocean.
We completely redefined what mass itself is.
It's no longer a solid chunk of matter you smash out of a vacuum. It is the geometric folding, the structural Euler sealing at the D3-dimensional gate.
We examined how dimensional friction calculated via the Ramanujan-Rogers attenuation drags on light, slowing it down from a perfect mathematical integer to the finite measurable speed we rely on.
Which gives texture to our reality.
Exactly.
We looked at how the Earth, acting as a massive spinning geometric knot, twists that textured vacuum, breaking the isotropic assumption of quantum chromodynamics and validating the long-ignored Brillat-Hall experiment.
And finally, we unlock the applied science fiction implications.
Tabletop antimatter via torsion chirality flips, stargates phase lock to atomic structural nodes, and zero-point energy extraction verified by golden ratio barcodes.
It is a complete, unified recoding of reality, from the quantum level to the cosmological scale.
So as we close this out, why should you, the listener, care about any of this?
Aside from the stargates, obviously.
Right, aside from the sci-fi tech. Why does it matter to your daily life if the universe is a bunch of isolated particles or a continuous geometric fractal field? I'll tell you why it matters. If this theoretical framework holds true, it profoundly changes your relationship with existence.
It really does.
It means you aren't just an isolated biological machine walking through an empty, indifferent void, disconnected from the space around you. You are a highly complex, densely folded, geometric expression of the universe itself.
Every single atom in your body, every chemical interaction, every breath you take is resonating at a perfect, mathematically balanced golden ratio.
You are physically, structurally woven into the continuous fabric of everything that is.
You are a localized, incredibly beautiful harmony playing out on an infinite crystalline lattice.
And I want to leave you with one final provocative thought.
Oh, here we go.
Something to mull over that builds on the geometry we've explored, but takes it one step further.
Okay, let's hear it.
We established that geometric closure on the D ladder creates stable, tangible things. The D2 to D3 gate creates physical mass. The D6 gate creates the strong torsion forces.
Right, the force is holding things together.
But the ladder doesn't stop. It goes on infinitely into deeper and deeper harmonic recursion. So what happens at the much higher dimensional tiers? What happens when the field folds itself at D15, or D100, or D1000?
The mathematics dictate that those higher tiers must produce structures of unimaginable complexity and integration.
But what if it's more than just physical structure? Could something as infinitely complex as human consciousness or the phenomena of life itself just be an inevitable Euler-sealed dimensional gate further up the fractal ladder?
Wow.
If the fundamental math of the universe naturally forces mass to exist at D3 just to resolve its geometric tension, does the exact same math, vibrating at a high enough dimensional frequency, naturally force us to exist?
Are we just the universe successfully sealing a higher dimensional equation?
Exactly. It suggests that life isn't a random accident in a dead vacuum, but a topological requirement of the field itself.
It is a staggering philosophical question.
That's the beauty of choosing to look at the water instead of just measuring the ripples. Thank you for joining us on this deep dive. Keep questioning the geometry of reality, look a little closer at the empty space around you, and we'll see you next time.